let's practice doing some multiplying. If we were going to multiply this type of problem together, what you would probably do is distribute the x first to get x squared minus 2x minus xi, and then distribute the minus 2 to get minus 2x plus 4 and plus 2i, and then distribute the I to get plus ix or xi and minus 2i and minus I squared, and then combine all the like terms. So I only see one x squared, then I have 2x and 2x right here, so minus 2x is minus 4x. Then we have minus xi and plus xi, so that makes 0. 4, and this guy is going to make plus 1, so 4 plus 1 is 5. And then plus 2i and minus 2i, they cancel. And there we go. And so it all simplifies down to something real nice. But it's that intermediate step that kind of takes a chunk of time. And so what I want to do is look at this problem again. X minus 2 plus I and x minus 2 minus I. And what I notice is that everything is the same except for this plus and this minus. Now usually when I have everything the same except for a plus or minus, it's a difference of 2 squares. And that's how I'm going to look at this, where this is my first term, x minus 2. And then I'll add and subtract the I. Then we do have the difference of 2 squares, where I would square the first thing and subtract the second thing squared. It's just that the first thing isn't an x. Now it's x minus 2. And the second thing is I. But when we square them, x minus 2 squared is easily x squared minus 4x plus 4. And then we'll subtract I squared. And we know that's plus 1. So 4 plus 1 is 5. And we get that same answer. So let me take this one, move it down here a little bit, and try and do this one in the same way, where I only see the difference of a plus and minus right here and here. So I'll separate it so that I'll have x plus 3 minus 2i and x plus 3 plus 2i. That'll give me x plus 3 squared minus 2i squared, the difference of 2 squares. X plus 3 squared is x squared plus 6x plus 9 minus 4i squared, which of course is the same thing as plus 4. So x squared plus 6x plus 9 plus 4 being 13. Now let's look at another type of problem, finding the function f if I know where the zeros are, that the zeros are at -1 and 3. So since the function is called f, I have to call it f of x. And since we know where the 2 zeros are, that means I know what 2 factors are. With 1 0 at -1, that comes from a factor of x plus 1. If the other 0 is at 3, that means its factor is x minus 3. So f of x, we just FOIL this out, and we'll get x squared minus 2x minus 3. And that's f of x. Now let's find the function g with zeros at -1 and 3i. Well, since it's g, we're going to call it g of x. The first 0 is at -1, so that means its factor is x plus 1. The second 0 is at 3i, so its factor is x minus 3i. But the problem with that is that if we were to FOIL this out, all of a sudden we have a polynomial that's got i's in it. And that's not a polynomial because it wouldn't have real coefficients. And the thing about polynomials is that these imaginary zeros happen in pairs. The other 0 is going to be -3i, so its factor will be x plus 3i. So anything that's imaginary happens in pairs. If one of them is 3i, the other one is -3i. And now we have to FOIL this out. I'm going to FOIL out the two imaginary factors first, because that'll be the difference of two squares of x squared minus 9i squared. So that is x squared plus 9. Now we FOIL the rest, getting x cubed plus 9x plus x squared plus 9. And of course, rewriting it so it's all nice and pretty. X cubed plus x squared plus 9x plus 9. Let's do one that's about as hard as I could possibly think of doing one. Find h of x with a double zero at -2 and another 0 at -3 minus 2i. Now the thing is, of course, if 1 0 is at -3 minus 2i, these things happen in pairs. Its pair is going to be its conjugate. -3 plus 2i will be the other 0. So this thing's going to have 4 zeros all together. Since the first 0 is a double zero at -2, that means the factor is going to be x plus 2 twice. Then, with another factor at, or another 0 of -3 minus 2i, then its factor is x minus -3 minus 2i. And its pair is going to be x minus -3 plus 2i. Now this is a lot of multiplying that's going to happen. But from the first two, that's not bad. X squared plus 4x plus 4. But in the second one, we got to look at it a little bit differently. X minus the -3 minus 2i. First, I'm going to distribute that negative. We'll have x plus 3 plus 2i. And the other one is going to be x plus 3 minus 2i. And again, we have this situation where within these two factors, everything's the same except for this plus and this minus. So what I'm going to do is separate it. And this way we'll have the difference of two squares. This first factor I'm leaving alone for right now. But over here we'll end up with x plus 3 squared minus 2i squared, the difference of two squares. So x plus 3 squared is x squared plus 6x plus 9. And minus 2i squared is minus 4i squared, or plus 4. And we have to FOIL now this x squared plus 4x plus 4 times x squared plus 6x plus 13. Not exactly easy, but not exactly horrible either. So we'll deal with the x squared first. X to the 4th, 6x cubed, and 13x squared. Then the 4x cubed, 24x squared, and 52x. And then the 4x squared, 24x, and 52. Combining like terms, we get that h of x is going to be x to the 4th. That's that one. Then my cubes, I got 6x cubed and 4x cubed. That's going to make 10x cubed. The squares, 13 squared and 24 squared is 37 squared. Plus another 4 is 41x squared. Then the x terms, I got a 52 and 24 makes 76. And we're left the constant of 52. And that is our h of x. And like I said, that's about as difficult as it can get.